I've turned off the lights because we are now in space. The Milky Way galaxy, to be exact, which is what you're kind of familiar with because it's where we live. And in the center of every galaxy, including the Milky Way galaxy, is a black hole. I'm just chilling in a spacesuit, probably connected to something, I don't know, but you guys are all just floating there, so hope you're having fun. You are kind of starting to go towards the black hole. Sorry about it. You guys are all stretching and contorting, and it looks as though you're moving in super slow motion. Some of you are trying to scream at me, but there is no air in space, so I can't hear you. It looks especially funny because you're moving in slow motion. You could try and get out your iPhone and maybe try and do like a Morse code, but the light waves do not travel well in space, and hell, I can't read Morse code anyway. When you reach the horizon, which is the outside, the very outside of the black hole, you freeze. So it looks as though your motionless body is just hanging there in space. But I watch it become slowly engulfed in flames. You guys are burning up. Sorry about it. As far as I'm aware, you're dead. You're reduced to ash. But from your point of view, you're just floating in the black hole. You're alive and just chilling. It's called free falling, which is what Einstein called his happiest thought. So while I think you're dead, you guys are just sitting there, chilling. It's a big enough black hole, because it is the one at the center of our galaxy, that you could just live there for almost the rest of your life, really, until you reach the singularity, which is the very center of the black hole. So if the black hole were actually smaller, you would be squished into a spaghetti noodle. So, you know, just be glad that this one is a big one. But you are all fortunate. You could live out the rest of your life, so congrats. So now that you're all living in a black hole for a while, I might as well talk to you about what a black hole is, the different kinds of black holes, and how they are formed. You may turn the lights on, Julie. Thank you. Now, what is a black hole? NASA's definition, going at the source, of a black hole is a point in space where there's a great amount of matter packed into a very small area. They have such a strong gravitational pull that not even light can escape. Albert Einstein first predicted the existence of black holes in 1916 with his general theory of relativity. According to Space.com, though, the first black hole wasn't spotted until 1971. So, yikes. I'm sure you now wonder what the different types of black holes are, obviously. There are stellar, supermassive, and intermediate black holes. Stellar black holes are the very smallest. Those are the ones that would have turned you into a spaghetti noodle. Supermassive black holes are the enormous ones, and I'm sure you guys may have known the song Supermassive Black Hole. Couldn't get that to play in the back, sorry about it. They are millions or even billions of times as massive as the sun, but about the same size and diameter because of the change in mass. The last kind of black hole is exactly as it sounds, somewhere in the middle, intermediate. They didn't predict that there was going to be any, that they could fit in the middle until very recently. They thought they were just small and large black holes. And now, besides the kinds of black holes, let's talk about how they are formed. When a star burns through the last of its fuel, the object may collapse or fall in on itself. For smaller stars, the new core will become a neutron star or a white dwarf. But when a larger star collapses, it continues to compress and create a smaller black hole. According to the Harvard-Smithsonian Center for Astrophysics, the Milky Way continues a few 100 million stellar black holes. Black holes actually have 3 layers: the outer and inner event horizon and the singularity. I think I already talked a little bit about the singularity, but I'll go back into that. The event horizon of a black hole is the boundary around the mouth of the black hole. That's where you guys were burning, sorry. Past that, light cannot escape. Once something passes into the event horizon, it cannot leave. The singularity is the middle. That is the single point in space-time where the mass of the black hole is concentrated. So, Caitlin, why should I care about black holes? Well, if you don't think that they're interesting, you're kind of crazy if you're not spooked by a large thing in space that traps everything, even light, at the center of our galaxy. That can take anything in, and it actually doesn't suck things in. The gravitational pull things just fall, and they continue falling forever. So in reality, you do not need to worry about falling into a black hole, but it's neat to think about. Thank you.